All right, folks, it's back in action here. In this video, we're going to very quickly go through some basic angle vocabulary. You'll notice that I already have the definitions typed out for you because these are just words we're going to be using that I just need you to be familiar with. So we're going to talk through these very quickly, and we're going to convert some ideas that you have about angles from your geometry days to now your trigonometry days. So the first thing we're going to take a look at is an angle, okay? When we look at this picture over here to the right-hand side, we all recognize that as an angle from our geometry days and our elementary and junior high days, okay? In trigonometry, though, an angle has motion to it, and most of the things we're going to be thinking about have a motion to it, and that's getting you ready for calculus where things are in motion. So an angle, okay, now in terms of trigonometry, is determined by rotating a ray, okay? So there's some type of a movement that has happened here. So this angle is not as much of a static thing as much as it's been formed by rotating something. The vertex is still going to be the same old thing that you've always been working at. That's still the common end point. And I'm going to come back to this rotating idea here in a second. Then we're going to have this idea of a standard position, okay? And for our purposes, every angle we think about is going to have started in the standard position. It will be in standard position. And that means that its initial side will be the positive x-axis. Now you might be wondering, what's an initial side? Well, that's our next thing. The initial side, okay, is the side of the angle that doesn't move, okay? So part of the angle is going to move and part of it won't. The part that moves is the terminal side. So they're both going to start in the same place, meaning they're both going to start in this positive x-axis position. So what we're going to do is we're going to take this angle that we have here and we're going to draw in an xy axis here. So we're going to take this nice horizontal side and we're going to extend that out so it looks like a nice horizontal axis. And then through the vertex, we're going to draw in our y-axis, okay? So now we can see that this angle is in what we call standard position. One of the sides of the angle is sitting on the positive x-axis, and then the other side has been moved. It's someplace else, okay? So this angle, what we actually understand, has been formed thinking that both of the rays of the angle started here and then one of them moved or rotated up in this case, okay? So the measure of an angle has been determined by how much our terminal side moved, okay? Where did it move and how far did it move? So in this case, it stopped somewhere in this first quadrant, but it was formed by rotating up. So we would call this the initial side, okay? In fact, both of the rays start here. This is our initial side. And then the terminal side is where it stopped. So this is the terminal side. So one stays in place and the other moves. So this is our terminal side, okay? Now, of course, it could rotate all the way around, and that's going to be a new idea for us because the terminal side didn't have to stop here. It could have stopped here, or in fact, it could stop down here, or in fact, could keep rotating around and around and around, and then just stop wherever it wants. Now, we also will have rotations that are both positive, that's the rotate up here, okay? Mathematically, we say that that's a counterclockwise. Okay, but you can think of this as a rotate up. That's okay, there's nothing wrong with that. Okay, rotate up. But because it's going to rotate up, what we're going to think about is back in the day, you learned that the quadrants were numbered 1, 2, 3, and 4, and you might have always thought that they seemed like they were numbered in a weird order. Why did they go in that direction? Because they're numbered in the order of rotating in a positive direction. Now, our angles could also rotate down, okay? So they could be a clockwise rotation. That's also possible. Okay, so they could rotate clockwise. In other words, they could rotate down. And that's also allowed. So we probably haven't seen that before. Both of our rays could start here, and it could actually rotate around this way and still land in that same place. That's also perfectly allowed, okay? So if you wanted to draw that on our pictures here, we could think of, oh, it rotated up or it rotated down. There's lots of ways that they could land. Now, I said up above that they could rotate around and around and around, and that's true. That additional rotations, that's going to create what we call coterminal angles, okay? And there's an infinite number of coterminal angles for any given angle. And we find those by adding or subtracting, okay? Depends what you want to find. We're going to add or subtract full rotations, okay? That's how we're going to find these. Now, in the next video, sorry, I got distracted there. Okay, add and subtract full rotations. I know that looks kind of funny, but you guys are okay with that, I'm sure. Rotation, there we go. All right, we're going to add and subtract full rotations. So let's say that I have an angle that is 120 degrees. Okay, if I'm thinking full rotations, I know that a full rotation is 360 degrees. So I can take this 120 and I can add to this 360, and you'll often see it with a K, meaning as many multiples of K as I want, so, or multiples of 360. So if K is 1, I add 1 rotation. If K is 2, I'm adding 2 rotations. So I could add that 360 as many times as I want, and I could get an infinite number. So 480 degrees is the same angle as 120, but I could keep adding and get to, I could, let's say, have 840, and I could keep going, okay? All of those, as I rotate around, would land in the same place as 120 degrees. I can also think of rotating in a negative direction. So I could subtract that 360K, meaning I can do it as many times as I want, and I could have a negative 240 degrees or a negative 600 degrees, as many as I want, and I could just keep rotating. Okay, so this idea of coterminal angles, we will see these a lot. So you just kind of want to get your head around recognizing full rotations so that you can visualize them in terms of their smallest numbers.